Hey everyone, and welcome to This Explainer. You know, every time you board an airplane, walk into a hospital, or step inside a towering skyscraper, there are these massive, invisible shields operating in the background, just working overtime to keep you safe. But how are they actually built? And, maybe more importantly, what happens when they fail? Today, we're going to unpack exactly how high-stakes industries manage the unthinkable.
Okay, here is our roadmap for today. We'll start with 1, the reality of risk. Then 2, evolving our safety culture. 3, humans, systems, and errors. 4, the global safety network. And finally, 5, who is ultimately responsible? Let's dive right in. To do this, we're drawing directly from a super authoritative source. We are unpacking a literal university course guide from the National Open University of Nigeria, and it's called Safety Management for Loss Prevention. It's an incredibly comprehensive text. It pulls together real-world case studies and data from aviation, healthcare, and construction, just to show us exactly how safety is maintained on a massive global scale.
All right, Section 1, the reality of risk, shattering the illusion of absolute safety. So let's start by boldly challenging a pretty common expectation. I want you to reflect on this for just a second. Is 100% safety actually possible? I mean, we naturally demand zero accidents, right? Especially when we travel or get medical care. But the source material is very clear here. While eliminating accidents is obviously highly desirable, 100% safety rate, it's literally an unachievable goal. There is absolutely no human activity or human-made system that can be guaranteed to be completely 100% free from risk. No way. And honestly, this brilliantly illustrates why we need a proper definition of what safety actually is. Safety is not the magical absence of danger. It's actually the state in which the risk of harm or damage is reduced to and maintained at or below an acceptable level through a continuing process of hazard identification and risk management. Basically, it's not a static bubble. It's an active, dynamic, continuous process. Now, to manage that danger, we have to understand risk itself. And risk is actually two-dimensional. It's the likelihood of an event occurring plus the severity of its potential consequences. Our source gives this fantastic hypothetical example to put this into perspective. Imagine the likelihood of a supporting cable snapping on a 100-passenger cable car is exactly the same as it snapping on a 12-passenger elevator. The probability? Identical. But the potential consequences, the severity of that cable car accident, are much, much higher, right? Therefore, the overall risk is entirely different, which means it requires a completely different level of mitigation. Moving on to Section 2, evolving our safety culture from reaction to prevention. Because we know risk is literally always present, our collective approach to managing it has had to transform dramatically over the years. Under the traditional perspective, safety was basically just reactive. Accidents happened, and the system reacted by punishing people and throwing down new rules just to meet some minimum standard. It was super compliance-focused and punitive. But, this approach only worked until the late 1970s, at which point accident rates just kind of leveled off. The modern perspective, however, it's proactive, it's data-driven, and crucially, non-punitive. Instead of sitting around waiting for a crash to happen, modern systems actively hunt for hazards using data, constantly seeking continuous system improvement. And this modern perspective builds into an absolutely vital and honestly completely counterintuitive finding from the text. It says, punishment drives reporting of errors underground. Think about it. If doctors, pilots, or engineers are terrified of being fired or sued for an honest mistake, they're going to hide their errors. And if those errors are hidden, the organization becomes completely blind to its own vulnerabilities, which makes everyone significantly less safe. It's a real eye-opener. Okay, Section 3, humans, systems, and errors, rethinking how mistakes happen.
So, if we aren't just blaming negligent individuals anymore, what are the core academic theories that actually explain why accidents still occur? Well, the first is systems theory. This theory clarifies that most errors are not caused by simple negligence or incompetence. Actually, scratch that. It's more like errors are symptoms of underlying upstream flaws in the systems themselves. The text calls these latent conditions. Think of things like inadequate staffing, flawed equipment, or just really poorly written policies. These latent conditions basically create an error-prone environment where human fallibility is pushed to its absolute limits.
The second framework here is human factors theory. The text states something pretty profound. We cannot change the human condition, but we can change the conditions under which humans work. Hit the nail on the head, right? It breaks down into 3 key principles. First, we've got to design systems that compensate for predictable human weaknesses, things like fatigue or memory lapses. Second, we have to make errors visible immediately so they can be intercepted before causing any actual harm. And third, we absolutely must develop strategies to soften the blow and mitigate the effects of those errors when they inevitably do occur.
Which brings us to Section 4, the Global Safety Network High-Stakes Case Studies. Let's ground all these abstract theories by taking a look at the massive, invisible safety networks operating right now within two absolutely critical fields: healthcare and aviation. In healthcare, medical uncertainty is just an ever-present reality. To navigate this, the industry relies heavily on continuous quality improvement tools, like the PDCA model you see here: plan, do, check, act. It's brilliant because it empowers the people who are closest to the actual care to test small-scale changes in real-work settings. If a new process prevents, say, a medication error, they check the results and act to implement it widely, essentially proactively redesigning error-prone processes on the fly.
Meanwhile, over in the aviation industry, the results of modern safety management are just staggering: 10 to the power of -6. To put that into perspective, that translates to an overall fatal accident rate in the vicinity of 1 fatal accident per 1 million flights. 1 in a million. This number really proves just how astonishingly effective modern proactive safety management systems actually are when they're applied rigorously. But, that 1 in a million safety record definitely doesn't happen by accident. It requires a dense, highly coordinated web of players. At the very top, you have IACO, the International Civil Aviation Organization, and they're the ones setting the global standards. Below them, individual states step in to provide the legal framework and regulatory oversight. Then, the manufacturers ensure the physical equipment is actually safe to use. And finally, the operators and service providers, like the airlines and air traffic controllers themselves, they're the ones implementing the daily safety management systems. It's like a giant puzzle, where every distinct tier contributes a vital layer to that invisible shield, keeping the flying public safe. And finally, Section 5. Who is ultimately responsible? The burden of leadership. Now, maintaining these massive, complex safety networks obviously carries an immense burden of leadership. So, who's ultimately holding the bag here? Well, the answer comes down to a concept called shared responsibility. We talked earlier about moving away from punishing individuals, right? The fascinating paradox here is that by removing the fear of punitive consequences, you actually force everyone in the organization to assume a much greater shared accountability. Instead of wasting time pointing fingers, the whole shebang shifts, and everyone becomes responsible for actively identifying weaknesses and collaborating to fix them.
That being said, our text explicitly notes that management teams do bear a very special responsibility. The safest organizations have a crystal-clear safety mission that starts at the very top. Leadership has to provide clear direction, allocate real financial resources and time, foster that non-punitive climate of open communication we just talked about, and genuinely prove that safety is a core corporate value. Without highly visible top-down commitment, safety management is, it's largely ineffective. And importantly, this responsibility extends way beyond the walls of a single company. Think about it. A single air disaster or a massive medical failure impacts the public's confidence in the entire industry. Because of this, fierce corporate competitors actually collaborate. Airlines and healthcare networks share vital safety data and work together to identify global hazards early on. They realize there is tremendous strength in collective action, and that at the end of the day, safety just makes excellent business sense. I want to wrap up our analysis with this incredibly profound takeaway straight from the text. An organization will never improve its process if it believes its people are the problem. If you take absolutely nothing else away from this explainer, remember this quote. It completely shifts how we must look at workplace mistakes forever. Blaming the human is just the easy way out. Fixing the system is how we truly manage risk. So, as we finish up today, I want to leave you with this provocative question. What invisible shields of safety are operating in the background of your life right now? The next time you step onto a plane or into a building, I really want you to think about the incredible systems, the shared accountability, and the continuous quality improvements actively working to keep you safe. Thank you so much for joining me on this explainer, and keep your curiosity alive.